I'm going to be giving a live demo today of Node.js and JavaScript. Don't think that Node.js is the only thing you're allowed to use with microservices. That is definitely not the case. We're going to be using Docker, and Docker allows you to host almost any language or runtime that you want. You can use Python, Ruby, Go, what other? There's Rust maybe. There's heaps of languages that you can use. I like to use Node.js with either JavaScript or TypeScript, mostly TypeScript these days. Let me explain why. To start with JavaScript, while it's not the world's best programming language, I'll concede that, I do believe it's the world's most practical language. You can do almost anything with JavaScript. Using Node.js means we can go truly full stack. It means we can go anywhere in our tech stack without changing language. So we can work on the front end in JavaScript, we can work on the back end in JavaScript, and so on. I personally use JavaScript and TypeScript across my whole stack, back ends, front ends, mobile applications, and more. Node.js, for its part, was made for this. It was made for building distributed applications. The name Node actually implies that Node.js is intended to be a node in a network-based application. So Node is network-orientated, and it includes all the fundamental building blocks that we need for creating networked applications. The fact that Node.js was built for this kind of thing makes building microservices with Node.js particularly easy, and I hope that's going to come across to you in the live demo, where I'm going to show you how easy it is to get started. Passing data between microservices is easy as well with Node.js, and that's because the de facto standard for communication between services on the internet is JSON, and that's something that's built into JavaScript, and indeed it was born from JavaScript. Now, you've also probably noticed that Node.js has a huge community. I mean, that can be overwhelming for newcomers, seeing that there is so much stuff out there. But just keep this in mind, there are a lot of tools, libraries, tutorials, other resources. That's a lot of things to help you get started and to get you the help that you need when you're learning. And more importantly, the community is so huge. So there are lots of people that you can lean on when you need help. And, reach out to us where some of us are really helpful, at least. Now, I think there's a bunch of other benefits to working with JavaScript, and I'm not going to go into those now. Hopefully, I've made my case for Node.js. This is a quick summary of the basic needs of a microservice. Typically, a microservice needs some way to communicate with other microservices and possibly the outside world. So it's got a bunch of communication requirements. It also needs to be able to store persistent data. So that's either data in a database or files in file storage or some other kind of storage. Today, we're going to keep things really simple, and we're just going to look at one simple microservice, and we're just going to give it some really basic communication facilities. So we're not going to go too far with this today, and we're not going to explore all these things, but I do explore all these things in my book, Bootstrapping Microservices, in quite some detail. We'll come back to that in a moment. It's a good time to start your prayers to the demo gods that this all works out for me today. Now, I'm using Windows 11. Now, it doesn't matter what operating system you use. Everything I show you should be the same. So you can do this under Mac OS, you can do this under Linux. It shouldn't make much of a difference. I have Node.js installed already, version 16.13.1. So if you need to install Node.js, it's pretty simple to install it on all the major platforms. Just visit the Node.js website. Obviously, I also have Docker because I'm going to be building a Docker image out of this at the end. I am running Docker 20.10.12. So to get Docker, I advise if you're on Windows or Mac OS, install Docker Desktop. It's really awesome. It's a little bit more difficult to get working on Windows than on Mac. And there is no Docker Desktop for Linux as far as I can tell. But you can also install Docker kind of in a more manual way on Linux if that's what you're using. I'm going to make, from scratch, a really simple Node.js application that could be the basis of a new microservice. So I'm going to start by creating a new directory called today. If you're on Mac OS, obviously you'd be using, or Linux, you'd be using makedir, not md. That's a Windows command. Now, to create like a stub Node.js program, we use npm init-y. So npm is the Node.js package manager. It's what we use normally for installing and uninstalling packages from the online Node.js package repository. npm init will basically create like a new kind of project for us, or a new package description. Using the -y command will just default it. So it's going to default to, so I don't have to type anything in basically. If you don't use -y, it's interactive and you have to do a bit of typing. So it just gives you this kind of basic setup. And if we look in the directory here, you can cat the package file. Oh, if you're wondering why I'm using Linux commands on Windows, it's because I think it's because I have Git for Windows installed, which comes with a bunch of useful Linux commands. So it makes using Windows a lot more like using Mac OS or Linux. Anyway, so I've just printed out the contents of the package file there. So this is the package file for Node.js, is the file that kind of manages the metadata for the projects and tracks all the packages and dependencies that we have installed. Let's create some code before I get to that next bit anyway. I'm going to open Visual Studio Code from this directory. At this point, I'm basically just going to start by creating a hello world program. So nothing too exciting. Here's my project open. You can see the package file. We can open the package file and have a look at what's in there. Actually, I don't want to create a file. I want to create a folder. So normally I have a src folder that contains my source code. The typical kind of main file for a Node.js project is called index.js. Sometimes people call it main.js or server.js or something like that. It's fairly common to call it index.js. That's what I like to call it. I'm just going to put a console log in here and just do a hello world. And now we're going to switch back to my terminal and run that. So we're starting pretty basic. So I'm running Node. But I'm going to I give it a file to run, index.js. We get our hello world. That's our starting point. Now, typically at this point, I've got some code. I've got a starting point. It's not much. This is where I might do like a git init to create a git repository. And then every subsequent change, I do a git commit and to save in my source control the results of my coding. I'm not going to worry about Git today. That's just adding unnecessary complexity. So let's just pretend that normally I would do that if I was making a microservice. What do I want to do to turn this hello world program into a very, very basic microservice? I need these communication tools. Communication to be able to kind of talk to other microservices or the outside world, or the ability to kind of accept incoming messages from other microservices. As I said earlier on, Node.js contains everything that we need to do network-based programming. The only problem is the Node.js APIs as they come, are very low level and a bit complicated and tricky. So most people don't use them. Most people install like a package from the npm from the Node package repository in order to make this kind of thing a little bit simpler. So that's what I'm going to do today as well. And the first package I'm going to install is Express. So Express is the kind of de facto standard framework for building a REST API or a web server in Node.js. So there's plenty of other options, like I'm using Happy on one project, I'm using Nest.js on another project I'm working on. Express just seems to be the most common and standard one, and actually most of my projects I've ever done have been on Express. So I'm exploring other options at the moment, but Express is still great, and it's still I think it's the de facto standard for Node.js. So I'm just going to install that. So this is going to allow us to handle incoming HTTP requests from other microservices and possibly from external services as well. So once I've installed that and I go back to Visual Studio Code, you can see here in the package file that I've got a dependency now. So it's tracked that dependency. So if I want to share this project with someone else, they just take a copy of it, or they take a clone of my repository and they do an npm install, and they'll automatically get all of the dependencies that I've installed for that project. Okay, so what are we going to do with Express? Well, I'm going to cheat. I'm going to actually go to the Express documentation and copy an example from there, which I've got open here. So this is just expressjs.com. I've just drilled into the hello world example. This is basically all I need, and I'm not going to do too much more than this. So rather than typing on all this code, I'm just going to copy that in. So it's a nice way to get started. I like semicolons. I can't read code without semicolons. And I'm also going to run the Visual Studio Code formatter to just get this in my standard formatting style. How nice does that look now? So this is just a simple program requires in the Express library creates an Express application. It's hard-coded to run on local port 3000. We've got a single HTTP route handler here that sends hello world back to the browser. And we're starting the application by listening for incoming HTTP requests. Now, if it starts up correctly, we should see this message printed, example app listening on port 3000. So let's start that. At the moment, I might try running my terminal and my code side by side. So to run this, I run my index.js, and I should have a web server listening on port 3000. Let's have a quick look at that. So let's look at localhost. Yep, that's it, localhost 3000. And if you can see that, it's pretty small. Let's zoom in. Hello world. So not terribly exciting yet, but we're getting there. We're getting there. Now, one thing I want to do is, you can see I'm changing code, I'm editing code. Every time I do that, I've got to stop the web server, I've got to start it again. That's a little bit of a pain. So I want to make this process a little bit faster. I want to have my web service automatically reload, what I call live reload, every time I edit my code. Now, before I do that, I just want to implement, in the script section here of the package.json, I want to implement a start script. I'll show you what this does in a moment. But my start script is going to run node source-index.js. So this is just what we were doing then. It's nothing different, except now that I've implemented that start script, I can use the npm convention npm start to start it. Now, the reason this is important is because it makes your project follow conventions. So typically, whatever Node.js project you get from your colleague or from some random open source person on the internet, if you run npm start, that's what's going to start it. And it doesn't matter whether you've got this index.js or whether you've called it main.js, it'll be set up here to start whatever the file is. And possibly also if it requires command line arguments, whatever it needs will automatically be configured to work on npm start. So it's just set up for nice, convenient, and whatever project you're working on, whatever microservice you're changing to, and you might be working on, a bunch of different microservices, whichever one you go to, you just have to remember npm start will start it. So that's a nice convention. Now, how I'm going to make this work with the live reload is I'm going to install Nodemon. So I'm saving that as a dev dependency. You can see here I've used save dev. So that means it's not a production dependency. This dependency is only for use in development. And what Nodemon does is it's like a drop-in replacement for Node, except it's going to watch my code files. And when my code files change it, it's automatically going to reload them. So you can see here it's added a dev dependency of Nodemon. Now, when you install this for production, when you want to run this on your production server, you're only going to install these production dependencies here. So you don't need Nodemon in production. Now I'm going to update my scripts here to include a new one, and this is not a Node.js convention. It's more my personal convention. Some other people use this or a similar convention. I'm going to run Nodemon, and I'm going to give it that JavaScript file. So this time, instead of running Node like we normally do in production, I'm going to run Nodemon. So this is for running in development. And one thing I have to add here, if you want to run this under Docker, I think you've got to add legacy watch. So unfortunately, the file system watching doesn't work out of the box, and it has to poll. This puts it in polling mode. You only need this if you're going to eventually run this project under Docker, like we're going to do. So now I can run npm, or I've got to use npm run. I've got to use the full sort of convention here because it's not a Node.js convention. npm run start dev. Now I should have an automatically reloading server. So let's say, you can see here what Nodemon is doing is it's saying it's watching for extensions. JS is the important one here. If it sees a change in a JavaScript file, it's automatically going to reload. And it's also run our code. So you can see here it's run our code under Node, and our web server is running. But I could put code here. I could say something like, now I'm going to save this file. And you can see here that Nodemon has said restarting due to changes. So it's starting it again, and this time it's printed that message. So this is a nice way of working where you can actually just keep coding and you don't have to kind of rerun your code. It automatically does that for you. Okay, so let's do a little bit more work on our server here so you can sort of get an idea of what we need. One thing we need is to be able to accept messages incoming from other microservices. So let's pretend that we've got one called, let's make this a to-do application. I know that's very cliche, but it does fit in with the data that I'm going to show you in a moment. Let's say if we get to-dos. So in this case, this is like a query from another microservice, and pretend this is the to-dos microservice that is responsible for getting the to-dos from somewhere and returning them for the other microservices. So we're getting a list of to-dos. That's sort of what the purpose of this is. So this is like a query. It could also be an action. Like it could be like we could use a post, a HTTP post, to add a to-do to the database. Or we use a get to retrieve a list of to-dos, or we have a get for maybe a single to-do to return. The reason I'm doing to-dos is because there's this great website called JSON Placeholder. It's great for experimenting with working with REST APIs, and it's just a REST API online. It gives you some examples using fetch. I'm not going to use fetch. I'm going to use Axios in a moment instead of fetch. But it's got a whole bunch of different endpoints. I'm going to use the to-dos endpoint, which you can look at by clicking on it. And so this is the kind of data that I'm going to be working with. It's just available online. For anyone to work with. I've got an endpoint here. I'm just going to test that I can do this. So that's going to restart my web page or restart my web server. I have to manually reload my web page to view it. But that's something you can deal with as well. In fact, I've got a blog post and a talk coming up on how to do live reload everywhere in the browser, in Docker. So stay tuned for that if you like this technique of live reload. I can test this here. Oops, got to add some parameters here, and the error message there is telling me that. Let's just refresh the browser. Get to-dos. So that's sort of my placeholder for where I'm going to actually get the to-dos and return them. Okay, so what am I doing? Oh yeah, I've got to install Axios. So like I said, Node.js has everything you need to do network operations, but it's pretty low level and pretty clunky to use. But you can use it and you can kind of set it up however you want. But most times we use these higher level libraries that makes our lives easier. One such library and kind of the de facto standard for making REST API requests is called Axios. So you might have heard of that because it's pretty popular. But that just makes, oops, forgot I did that. I forgot to do the install command correctly. So Axios will just make our lives a little bit easier when we're making requests to other microservices. Just to make this move a little bit quicker, I'm going to copy some code that I've got on my cheat sheet here. So let's just import Axios. So we're just importing the Axios module there so we can use it. Actually, I'll just type this in and I'll have to copy the URL because it's kind of long. So I'm going to do a HTTP GET request using Axios. Now let me see if I can find the thing I'm looking for here. This is the actual, if I go into this to-dos here, this is like literally what I want. I'm just copying from the address bar here. I'm just copying that. And I'm gonna send my GET request at that. Now let's just do that first. And then, so we'll chain up like a handler on, a promise handler on here to get the response. And the first thing I want to do is just print the response to see what happens. I'm going to print the data in the response. And then there could be an error. There could be an error there. And if I don't have a catch handler, I might miss that error. So just to make sure, you know, like if I put a typo here or something like that, that would cause an error probably. And I might not be able to see that if I didn't have the catch. But let's log the error. So just so I can make that error visible, just in case there is a problem. And I'm just going to send something back anyway. I'll change that in just a moment. So I've got to restart this now after I've installed Axios. And what I'm looking for here is I should be able to kind of hit this to-dos endpoint in the browser. So by the way, I'm just testing from the browser here, but there are other ways to test REST APIs. You might have heard of Postman. That's a really popular one. But in VS Code REST client, there's a really good one called, in Visual Studio Code, there's a really good plugin called VS REST client. VS REST client. Google that. That's a really good way, because this will only get you so far. Doing it in the browser will only get you so far. It works for us today. So I'm just gonna. Oh, where's my example? Here we go. I'm just going to refresh this browser here, and we should see on the side here, on the left-hand side, my console log. There we go. So you can see here a lot of to-do items have been printed out, and it's returned the 1, 2, 3 string that I'd coded in there. Now what we want to do is we just want to send JSON back. So we're responding with JSON, and to keep it simple, I'm just going to return all the data. Now, you know what this is going to do? Actually, before I run this, just for completeness, if there is an error, I don't want to just leave the browser hanging. I want to send a status code of, you know, something went wrong in the server. Status code 500, which is a standard. That's part of the standard HTTP status codes. So I'll go back to here. Now, when I refresh this, you should see, too zoomed in, let's zoom out. But here you can see there's a massive list of to-dos being returned in JSON format. So you just have to pretend here that instead of this being in the browser, that another microservice is making this request to get the list of to-dos from the to-do service, and it's getting back this list of data. Now, normally it wouldn't look this nice, but I've got a plugin here that I think is just called, you know, JSON plugin or something like that, that formats it really nicely in the browser. Let's look at what else you could do with this system. So you would also want maybe HTTP post to to-dos, and you would say that here, this is where maybe a to-do gets added. And you can have as many of these handlers as you want to handle incoming messages or query requests from other microservices. I'm not going to worry about filling that out. So you can imagine that, you know, and in this case here, we're actually like, this simulates forwarding a request to another microservice. In this case, because I don't have another microservice, I've only created the first microservice, so there can't be another microservice yet. But just imagine that this is talking to another microservice, but in reality, it's talking to an outside service, an external website. But this could also be, you know, something like, you know, do a database query and return to-dos from database. So, you know, that is what this might actually do instead. But I'm going to leave it as is because I want to demonstrate this in Docker now, and I don't want to break my code. So I'm going to put it back to the way it was. I'm just going to do a quick test to make sure that that is working. So when I put it in Docker, it's going to be all good. So there's not much here. I mean, this is like 25 lines of code, right? But I'm sure you'll agree that this is a simple, effective way of getting started on building a microservice. There's much more you can add to this. We'll talk about that in a moment, about, you know, what are the more advanced aspects of microservices. But, you know, believe it or not, though, this simple bit of code, this is just simply a great starting point for a microservice. Let's Dockerize this.